Okay, tonight we're going to look at solving a quadratic equation using the quadratic formula. So you're going to want to pause this video and write down the formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c. And that's all divided by 2 times a. So this is the formula that's going to get you the solutions to a quadratic equation. So the first thing you want to do is make sure your quadratic equation is in standard form. Okay? And so since we are solving, we're going to want to make our equation equal to 0 for y. So starting off with example 1. If you haven't paused the video yet, I would pause it now and write this stuff down. So, looking at our first example, we know it's quadratic because the degree of the polynomial is 2. That's the highest exponent. Okay? And so, first thing we want to do is get this into standard form. So, I'm going to go ahead and set this equation equal to 0. So, I'm going to cancel these terms on the right. And remember, whatever you do to one side of an equation, you have to do to the other side. So we subtracted the 8x to cancel that one out. We subtracted the 10 to cancel that one out. So now on the left side, we're left with 2x squared minus 8x minus 10. And that's going to be equal to 0. Next thing we're going to do is we're going to label our A, B, and C so that we can easily put it into our formula. So we know that this is going to be A, this is going to be B, and this number is going to be C. So let's go ahead and plug them in and then solve it. So we have x equals, okay, negative, and then our b value is negative 8, plus or minus. That tells us there's going to be two answers. The square root, okay, plugging the b in, since our b is negative 8, please put it into a parentheses, minus 4, and then plugging in the a value, which is 2, plugging in the c value, which is negative 10, and we're going to divide that whole thing by 2 times a, which is 2. Now the next thing we want to do here is we want to go ahead and simplify this side over here. So 2 negatives make a positive. Negative 8 squared is 64. And we have negative 8 times negative 10, which is positive 80. And 2 times 2 is 4. So I'm going to go ahead and move this direction now. So we're going to have 8 plus or minus the square root of 64 plus 80. That's going to be 144 over 4. Continuing to simplify, we'll have 8 plus or minus the square root of 144 is 12 over 4. Now at this point, we're going to go ahead and split this up into two problems. So the first problem is going to be the plus. So we're going to have 8 plus 12 over 4. That's going to give us one of our answers. And then the other one, we'll use the minus. 8 minus 12 over 4. Okay. And then we have our two solutions. Now, so that you can see these solutions, if I plug the equation into my calculator, and yes, I'm using the old school calculator because old school rocks. So there is our equation in standard form. Our solutions are 5 and -1. We can see that by looking at our graph. We can see it crosses at -1 and it crosses at 5. We can also see it in the table. You can see the two zeros right here, -1, 0, and 5, 0. Okay, so there you have it. Those are our two solutions. So let's take a look at another example. But before we do, let's really quickly categorize these solutions here, what type of solutions these are. So these are rational solutions. Rational solutions. What makes them rational? If you'll notice the word ratio. The word ratio means fraction. Both of these numbers can be put into fraction form. If I put it over 1 or I put that number over 1, then they're both fractions. So anytime a number can be put into fraction form, then you have a rational number. Okay, so let's look at another example. I'm going to go a little bit quicker because there's a lot I want to talk about. I'm going to go ahead and start off in standard form. I think you guys know how to get to standard form, so I don't have to mix it up. And let's plug it in real quick here. So x equals -b plus or minus the square root of b squared minus 4 times a times c, and that's going to be over 2 times a. So remember, this is a, the invisible 1 is b, and the 5 is c. So simplifying this, -4 times 3 is -12. -12 times 5 is -60. And that's going to be over 6. Continuing to simplify, we have the square root of -59. Continuing to simplify, remember that the negative in here is a -1. The square root of -1 times the square root of 59. So that's going to be I. Square root of 59 can't be simplified. Over 6. And those are going to be our two answers. Remember, we use the plus for one answer and the minus for the other. So here's our two answers. And since they're imaginary, this type of solution is complex. All right, so now let's take a look and see what that looks like on our old school calculator. So there's our equation. If we graph it, notice that the quadratic, the parabola, does not cross the x-axis anywhere. And so only real solutions will touch or cross the x-axis. This one's not a real solution, and so we call those complex solutions. If you do get any answers that look like have a radical in the answer, but not an imaginary number, that would be an irrational solution. So an example, I'm not going to do a whole problem here, But an example of an irrational solutions would be, for example, if we had 3 plus or minus the square root of 7. Okay, since we have a radical, the square root of 7 in here, notice it's not imaginary, there's no negative in here, okay, to pull out as an I. Okay, there's just a radical here, so anytime you have a radical in your answer, you're going to have irrational solution. And you need to know the different types. If it turns out to be a number that can be put into fraction form, it's rational. If it has an imaginary part, okay, then it's complex. If it has a radical, only a radical, no imaginary part, then it's irrational. This is not irrational because it has an imaginary part. So that makes it complex. So I hope that makes sense to you. Okay, the next thing I want to cover really quick, and I am taking a long time on this video, a lot of information, but you need to know that this under here, under the radical, this portion right here, this is known as the discriminant. Discriminant. I can't spell. Discriminant. And if this number here, whatever this comes out to be, if you simplify this, okay, and it comes out to be less than 0, okay, if this discriminant turns out to be less than 0, you have a complex, two complex solutions. If this turns out to be greater than 0, okay, you're going to have two real solutions. I'm running out of room. Two real solutions. And if it turns out to be equal to 0, then you have one real solution. But it's that one solution, it occurs 2 times. It's called a double root. It's like x equals 5 and x equals 5. Just the same solution twice. Okay, so finally in wrapping up, just to recap here, if the discriminant, if this value under the radical is less than 0, we have 2 complex solutions. If it's greater than 0, we have 2 real solutions. X equals 2, x equals 3. If the value under here is equal to 0, then we have one real solution. But just realize that one real solution occurs twice. Like, for example, x equals 4, x equals 4. It's the same solution twice. Okay, well, I'll see you in class tomorrow. I'll be checking your video notes. This will be your first video note grade of the second semester. Later.